Okay guys, so this time we're going to be multiplying radicals. Okay, the rule says that we multiply the numbers outside the radical and then the numbers inside the radical separate. In this case, I don't have any numbers outside the radical, so I'm just going to go ahead and multiply the numbers inside the radical. So that's going to give me square root of 3 times 2 is 6, and that's the end of it. Okay, now we do the next one. Same thing, we just got numbers inside the radical. We're going to multiply them together to get square root of 50. But unlike that 6, which is already in simplest form, I could do a prime factorization on that 50. So I'm going to go ahead and do that. I'm going to go to the side and divide by 2, 25 by 5, 5 by 5, 1, 5 radical 2. Okay guys, never leave the radical unsimplified. You have to be careful and simplify every time you get your final answer. Okay, so that's it. This time we're gonna go ahead and do the same thing, but now we have numbers outside the radical, so we're gonna multiply the two numbers outside the radical. That's gonna give you 11 times 4 is 44, and then we multiply the numbers inside the radical together to get 10. Right, but we know that 10 is already in simplest form. If you try to do a prime factorization, you're not going to get any pairs. Therefore, that's my final answer right there. Okay, let's move on to the next one. Same thing, we multiply the numbers outside the radical. 2 times 5 is 10, and then we get 6 times 3, 18. 18 is now in simplest form, so I'm going to go to the side and do a prime factorization on 18. Divide by 2, 9, by 3, 3, by 3, 1. So that's going to give you 3 radical 2. So 18 itself is 3 radical 2. But don't forget that there's a 10 outside already, so I multiply 3 times 10, right, to get 30 radical 2, and that's going to be my final answer. Move on to the next one. Again, we multiply the numbers outside the radical. That's going to give us 2 times 6 is 12. And then the inside numbers gives you 36. But without having to do a prime factorization, I noticed that 36 is already, it's a perfect square, so I know that the square root of 36 is 6, right? Just 6, no radicals, because it is a perfect square. So you're gonna go ahead and multiply 2 times 6, right? Because square root of 36 is 6, and that's gonna give you 72. Okay, so that's gonna be the answer. Again, no radicals, because we have a perfect square inside the radical. Okay, so copy that. Okay, so our next example, we're gonna do it 2 different ways. The first way I'm gonna do it is I'm gonna go ahead and multiply the 2 numbers inside the radical to get 20 times 18 is 360, and then do a prime factorization on that number. We divide by 2, 180 by 290 by 2, 45, by 5, 9, by 3, 3, and by 3, 1. So let's circle pairs together. So I get 3 times 2 is 6, 6 radical 10. So that's gonna give me 6 radical 10. And now let me do the same problem a different way. Let me do let's do square root of 20 times square root of 18. So I'm gonna do a prime factorization on both numbers. For 20, divide by 2, 10 by 2, 5 by 5, 1. So that's gonna give you 2 radical 5. We do the same thing with the 18, divided by 2. 9 by 3, 3, and by 3, 1. So it'll be 3 radical 2 times 3 radical 2. And then we multiply them together. Multiply the outside numbers. 2 times 3 is 6. And then radical 5 times 2 is 10. 6 radical 10. Notice how we get the same exact answer. You could do it either way. Some people prefer to do it this way, so you don't deal with numbers that big, like 360 or even bigger. But you could do it either way. Okay guys, down to the last 3 examples. Okay, let's keep doing the same thing we've been doing. This time we're gonna be dealing with variables. Okay, but it's not that hard. We multiply, again, we multiply the inside numbers to get square root of 3 times 6 is 18. And then we add the exponents for the variables. 1 plus 7 is 8. X 8. At this point we're gonna do it separate. We do the 18 in simplest form because it's not a perfect square. To divide by 2, 9, by 3, and by 3. So 3 radical 2. So as far as the numbers go, I got 3 radical 2. If you notice, I'm leaving space in between to get the variable. In this case, I have a perfect square because whenever the exponent is even, it is a perfect square. Just divided by 2. And it goes outside. So that's going to be my final answer. Very good. Next one. Multiply what's inside the radical. So I get 16. 2 times 8 is 16. A 1 plus 1 is 2. A squared. So we know the square root of 16 is 40. This is a perfect square, and so is a squared. Square root of a squared is 8. So that's going to be my answer for A. No simplifying was required because the number and the variable were perfect squares. We got this to the last one. We multiply the numbers. 5 times 15 is 75. X to the third times x to the 6 is x to the 9th. We do a prime factorization on 75. Divide by 3. 25 by 5. 5 by 5. 1. So it's 5 radical 3. So as far as the numbers go, I got a 5 and a 3 inside. Now when it comes to odd exponents, right? Whenever the exponent is odd, this will not be a perfect square. But I'm trying to get as much as possible outside of the radical, so I just go 1 down to get x to the 8th, right? X to the 8th times x to the 1 is x to the 9th. But now I'll be able to get the x to the 8th outside the radical because the square root of x to the 8th is x to the 4th. and then whenever you get an odd exponent, you're always gonna get the x to the 1 left inside the radical. And that's gonna be my final answer right there.